Welcome to TeleGeography Explains the Internet, the show that explores the business behind all of the ways humans stay connected around the world. I'm your host, Greg Bryan, and today we are wrapping up our 5-part series explaining exactly how data actually moves around the world. If you didn't listen to the first 4 episodes in this series, stop now. Go back and check those out first, as each episode kind of builds on the previous one. And once again, rather than my normal free-form interview format, I'm going to enlist the help of a colleague and do the rest of it solo. Particularly in this case, because this happens to be my area of focus at TeleGeography. So as I've been saying in all of these episodes, we know that most of our audience works in the telecom industry or with networks, but our goal here has been to pull back from those day-to-day jobs and highlight the nuts and bolts of the whole ecosystem, if I can use that word. My hope is that you might save these episodes for reference, pass them on to friends or colleagues that might want to know more about the telecom world, or see how your portion of whatever you do in the telecom business might fit into the bigger picture. And certainly if you just found this episode, you're not in the industry, but you're just curious about how the internet or telecoms in general work, I think this series will still be totally accessible to you. Just especially for this one, go back and listen to the others first. So far what we've covered is episode 1, how does the internet work? Episode 2, what is the transport network? Episode 3, what are data centers? Episode 4, what is the cloud? And on episode 5, the final one, we're going to tackle what is a WAN. Let's get the definition out of the way. WAN means wide area network, which came out of the term LAN, or local area network. If you are an older gamer, you might recall LAN parties where to play each other in video games, you would actually bring PCs together into a room and physically connect them with Ethernet, Cat5, Cat6 kind of cables. The WAN is really the same idea. It's just those wires are stretched across the world or the country maybe instead of across a room. So this really all goes back to corporations first needing private networks. The original private WANs were directly related to something that we already discussed in a couple of previous episodes that at least touch on, which is on-premises data centers. When corporations started moving towards digital transformation or making all kinds of business processes computer-based instead of analog, they needed to connect certain offices to the data centers that way they set up in larger headquarters or campuses. So if you're old enough, imagine a filing cabinet, if you still know what that is, full of papers. As corporations move to this digital transformation world where we take the data, the information that are in those filing cabinets, we put them onto computers. Those computers were in the basements or some closet of a corporate headquarters or a campus, and we need to pull wires between all the various offices and those locations. So at first, this was primarily a network of what we call in the industry private lines. We discussed those in the transport network episode. But the upshot is that just like it sounds, a corporate customer would reserve a line on a carrier's network that really belonged entirely to them for a defined amount of bandwidth. Back then, it was usually what we called protected service, meaning that that private line was a ring rather than a single straight line, so that it could be self-healing if there was a fault on one line. A corporation would then lease a private line, at this time, usually something we called SONET or SDH, which again, we touched on briefly in the transport episode. But they would lease that from a carrier to directly connect an office to a data center, usually in a site that they owned. This was often called a hub and spoke setup because all of the lines would converge from various offices to those data centers. So imagine a data center headquarters in the center, and then a bunch of little satellite offices around that, like the hub and spoke of a wheel on your bicycle. A company might purchase private lines for their key offices in North America back to the headquarters in New York City, for example. And then perhaps they do the same thing with their European offices or sites back to a headquarters in Paris or Frankfurt. The advantage here is that these lease lines belonged entirely to that corporation as far as the network is concerned. So they were secure and protected and did not get involved in traffic jams that you might get on the public internet. Those resources were dedicated by the carrier to that company's use. Eventually, the digital transformation of corporate processes became complete enough that they needed many such lines in redundant connections to allow data to flow between the offices themselves rather than just routing through the headquarters or data center sites and then back out. As you can imagine, redundant private lines between all offices could not only grow exponentially in number, but also get prohibitively expensive. So, around this time, which I should say was maybe the turn of the millennium or so, where during the 80s and 90s, private lines, really during the 90s, private lines were what corporations were using for this. Around the turn of the millennium, the early 2000s, there was a brief period when carriers might use technologies called frame relay or ATM as an alternative to this for enterprise WANs. Their period of prominence in the market for this purpose was so brief that I only want to mention them here by name to get it out there that was a thing. And to say that they played a role in the coming switch away from point-to-point private lines towards what we call an any-to-any WAN service after something called MPLS comes along. So we're just going to leave frame relay and ATM aside, know that they happen. But the big change away from this private line kind of network with exponential endpoints connected to each other was when MPLS came along. So to get it out of the way, MPLS stands for multi-protocol label switching. And the name itself is actually fairly instructive. One of the key features of MPLS early on was that it was layer 2.5, as some people called it, or basically able to mix together layer 2 switching and layer 3 routing. So kind of like Ethernet plus the internet. Now, there are several features of MPLS that are worth highlighting here, I think, in the development of the WAN as we've come to know it. First, in its early days, MPLS was often used interchangeably with the term VPN or virtual private network. I think it's worth pointing out here that this is very different from what we as consumers now call a VPN, or would have it even back then, but that just secures your device's traffic over the public internet using protocols such as IPsec, for example. So while MPLS was a type of VPN, it's very different in that rather than just creating a tunnel or a sort of private secure path for a single link across the mesh of the public internet infrastructure, MPLS creates virtual private networks across a carrier's MPLS network that connect their sites all around the world. Second, I've mentioned any-to-any, but I wanted to make sure that what I mean by that is really clear. So in a private line network, this hub and spoke kind of setup, I could send data only between two defined points, like city A and city B. So if I have an office in Charleston, South Carolina, that is connected to my data center in Washington, D.C., and then another office in Atlanta, Georgia, that is also connected to that Washington data center, I would have these single connections between Charleston and DC and Atlanta and DC, but not between Atlanta and Charleston in many cases. So traffic from Charleston that was destined for Atlanta would have to trombone, as we call it, up to Washington and then back down to Atlanta. And this can become incredibly complex if you're going from instead maybe Charleston to Singapore, as you can imagine, right? So as private line networks grew and the needs to connect specific offices grew, those lines started getting really complex and expensive, like I said. The solution was an any-to-any network where the Charleston office would be connected to what we call a port, really a sort of port of entry onto the carrier's backbone network, switched like the internet, right? Routed like the internet, I should say, at a POP or point of presence in Charleston. And then that traffic would be able to get to any endpoints on that company's WAN anywhere around the world. So the essential idea of any-to-any, which is different from the private line, which was usually point-to-point or sometimes what you call point-to-multipoint, is that traffic doesn't have to make all these hops, or you don't have to have specific lines between locations that are dedicated to you. You get onto the carrier's infrastructure, then your traffic is tunneled across their global network or their regional network and can get to any of your sites as long as they have a local access connection to a POP in a nearby city. So, third, MPLS came up with something called class of service levels. This allowed companies to tag certain traffic with special header codes that would give those packets priority at any crowded routers. This is kind of like a fast pass at an amusement park. So in the private line network, customers didn't have to worry that their packets would get in a traffic jam because those lines belong to them. But any-to-any service requires that packets from all different users, other companies, etc., are hitting the same routers in that shared infrastructure backbone network. So with class of service, customers were able to designate a certain amount of traffic in that port for latency-sensitive applications like voice and video to always get to the front of the line. So when your voice and video packets get to a router, they get to say, hey, my timing, my latency is really important. I get to go in front of everybody else and make sure I get to my destination in the right order and the right time. Finally, because MPLS does not run over the existing public internet, carriers had to build out their own MPLS infrastructure or lease it from other carriers where they didn't have network, and this has a cost that's much different and higher than internet infrastructure. So while MPLS was affordable as an any-to-any technology compared to those exponential individual private lines, it was still expensive compared to sending traffic over the public internet. But the public internet wasn't secure enough, nor could users guarantee that their latency sensitive or important packets would get through in time or in the right order. So MPLS really became the dominant network technology for wide area networks, all of the ways that most corporations would connect their offices for about a decade. So from about the mid 2000s or aughts, depending on how you like to call that decade. We've never really landed on anything. But from about the mid 2000s, MPLS was coming out as a popular technology in about 2005. That got disrupted in then the mid to late teens by something called SD-WAN. So we were running a conference series all about WANs at that time. And I recall the first time I was literally on stage and the first time I heard about SD-WAN and had to kind of process that in real time. So I remember exactly where I was. Although, we had heard about things that were that concept, but the first time I actually heard that term. And what it was the promise of allowing corporations to use the internet, which was much cheaper, is still much cheaper than MPLS for their WAN traffic. So what is SD-WAN? Well, first, it simply stands for Software Defined WAN. So it's kind of bringing a sort of AI-like technology into how the WAN works. But it represented this revolution in corporate networks, at least as impactful as MPLS had been a decade before that. Now, I am the resident WAN expert at TeleGeography, I'm comfortable saying, but my colleague Brianna Boudreau is our SD-WAN guru. So I'm going to have her on to answer a few questions to explain SD-WAN and its impact in greater detail. Welcome to this final Explainer episode, Brianna. Thanks for coming.
Thanks for having me, Greg. It's great to be back on the pod.
Yes. So, Brianna, I'm in this episode, as you will hear when it's all put together, sort of going through the history of what a WAN is in the context of our bigger conversation of just like, what is the telecom world like? I could talk about all the WAN stuff, but you, as the principal investigator of our SD-WAN product, I thought would have some better insights than me onto exactly what role SD-WAN played in changing how the WAN works. So that's kind of where I'm going with all of this. But I thought first, can you just tell us at a high level, this is a explainer series, right? What is SD-WAN and what does it do?
So SD-WAN is a technology that uses software-defined networking to steer traffic securely and reliably across the WAN. So the technology itself is generally a network overlay that uses an enterprise's existing network services in the underlay. SD-WAN appliances or SD-WAN software downloaded onto a UCPE sit at each network site and connect to a centralized controller, either in the data center or the cloud. WAN managers can go in via a customer portal to those controllers, and they can configure different policies for different applications. And your SD-WAN will route your traffic across various network underlay technologies based on which links meet these application performance standards. So, for example, an enterprise could create a policy that says they always want this video application routed over MPLS because it is sensitive, and to route their less sensitive traffic over internet. Or they could go in and say, I would like that video application routed over their DIA connection until latency or jitter reaches a certain threshold. Then the SD-WAN can dynamically reroute it back to MPLS, so there's no degradation into the service.
Mm-hmm. So you brought up a couple terms there that I want to sort of circle back on just to make sure that we outline what those are, like underlay and overlay. Can you flesh that out a little bit, because it is terms of art within the SD-WAN world, right? So,
no, sure. For a long time, there were a lot of issues integrating internet into the WAN because of security and performance reasons. And so that's why MPLS, with its class of service assurances, was such a popular tool for end users. And so really, SD-WAN came along as a way to integrate internet, such as DIA or broadband, those network underlay services, alongside MPLS in the WAN. And it kind of overlays and coordinates all of those services together for end users.
So we can think of like there's the WAN where the bits are actually moving through the wires and getting routed, and SD-WAN is an over-the-top kind of service that sits above that, telling it what to do.
Exactly.
Got it. Okay, that makes sense. So you touch on this, but let's focus in a little bit more on why SD-WAN allowed an enterprise to say, okay, well, maybe I don't need MPLS everywhere anymore and can integrate internet into my WAN because internet is cheaper and things like that. I was scared to use it before. What are some of the specific features that SD-WAN brought to the table that allowed folks to say, hey, I can minimize my MPLS usage or maybe get rid of it in a lot of places?
Sure. So SD-WAN sits atop all of those network services, and it continuously monitors network performance. Mm-hmm. So it establishes tunnels between different gateways across your multiple links, and it takes measurements of features such as jitter, packet loss, latency, and throughput. When no end user traffic is flowing, it can use a synthetic probe to even monitor network performance. And then it routes that application traffic accordingly based on these measurements. It's also using approaches such as forward error correction to correct for any errors in data transmission by sending redundant data across a network in anticipation of those drop packets. Similarly, line testing, actively monitoring the performance of your different network connections, and then routing traffic dynamically, where for a long time people used class of services with MPLS to make sure that they were routing traffic over the best performing link. SD-WAN can do that in real time. If one of your links reaches a certain threshold for latency or packet loss that's affecting your application performance, it'll dynamically in real time shift it over to a better performing link in your network.
Right. And the upshot for corporations setting up a network is that this is cheaper than MPLS, right? So,
it is. You can integrate those cost-effective services alongside MPLS. So you may not want to entirely get rid of MPLS, but you can significantly reduce the amount in your network without sacrificing application performance.
Got it. All right. So the last thing I want to touch on is around what we in the WAN world call policies. So like in this context, like policy means rules about how your network works and security and things like that, and specific applications. How did SD-WAN sort of change the game in terms of how network managers could send policies across the network and look at specific applications? So to be clear, what I mean by that is that in the WAN world as it was pre-SD-WAN, applications just were part of what went over the network. If something was down or not performing, it was the network wasn't performing. And always at that time, you remember this, I'm sure as well, we would hear, and this is in like the late teens or whatever, you would hear network managers saying, I wish that I could have like an SLA that attached to my application, not to just my network. What does SD-WAN do to sort of get us to that world where it's about how a particular application or use of the network matters, not just is the network on, right?
For sure. So SD-WAN really, it's very customizable for enterprises, and you can kind of right size the network for what application you're using. So WAN managers can go in via a customer portal and look at all their different applications and set policies based on applications, groups of end users, different security requirements, or even the location of some end users. So there's a high level of customization here, which is helpful if you think about it, because a lot of those cloud applications that we're all using now are designed to perform better over the public internet. And so SD-WAN is really allowing...
born on the internet. Sorry to interrupt, but
so SD-WAN really allows you to go in and set policies for those so that you are ensuring the best performance for a lot of those applications.
Mm-hmm. Yeah, that makes sense. And I think to wrap it up, what you brought up there is super important in terms of how this all works out for folks, again, networking corporate sites, is that sort of customer portal, that visibility and the ability to change things dynamically and that sort of thing was something that really, again, wasn't there in the previous WAN world, where it was just there's the network and the network is either working or it's not, right? So,
exactly. It was a game changer for sure.
Awesome. Well, thank you so much, Brianna. I think that makes a lot of sense.
All right. Thank you, Greg.
All right. Cheers. All right, so I hope that made clear what SD-WAN is, why it changed the WAN. But one thing I wanted to focus on before we wrap this up is to understand internet use as a WAN technology by the corporation. So while the public internet is, as we discussed way back in episode 1 of this series, it is a network of networks. There are a couple of different ways that corporations can connect with that network of network, being what we call the public internet. So the first one is business broadband, and this is really a service very similar to what you have at home. It's just access onto the internet. For businesses, it might come with a few more guarantees about downtime and performance. But like your service at home, it's what we call a contended service, meaning that your provider or ISP is sharing that infrastructure across many different customers and not guaranteeing that that specific bandwidth is being applied to you as an individual customer. In other words, if you get 100 megabits of service from your ISP, chances are really good, run a speed test, that you're never actually seeing 100 megabits per second of service, because other people might be using that infrastructure at the same time, which is going to cause your bandwidth to go down and maybe sometimes your performance to be poor. A lot of you probably experienced this, particularly at the start of COVID, when you had, I know in my household, I was working from home before COVID, but then my wife came home, my 3 kids started doing online school or gaming or watching Netflix or whatever at the same time. And all of a sudden, everybody else in the whole neighborhood was doing that as well. And things really weren't up to the same performance that I was used to. Now, carriers, of course, took care of that and got used to it so that folks could have the performance they were after. But the point is that businesses don't want to be in a position where they don't know if their internet is going to be performing at the level that they need. So there's another product called Dedicated Internet Access, or DIA, that is more enterprise grade internet service in that it is uncontended, meaning if you buy 100 megabits of service, your carrier has engineered the network so that you always have that 100 megabits of service dedicated to you. It also comes with something we call SLAs, or service level agreements, that guarantee certain performance metrics around like latency and things like that, or they will give you credit on your monthly bill if they don't live up to those SLAs. So certainly some corporations can get by with using business broadband, particularly where really high bandwidth circuits are available. But a lot of them are going to prefer this dedicated internet access that has more of a WAN-like sort of guarantee about the performance. Okay, so finally, changes in the WAN. Along with SD-WAN, there's been several other big changes to how corporate networks are set up in the past decade that I think are worth touching on briefly. The first one we addressed in our previous episodes about cloud and data centers, which is namely the migration of the data center off corporate premises and the broad shift to cloud-based applications and data services. Both of these related changes have had a huge impact on how the WAN is set up. While corporations used to be simply connecting their own sites to each other, they now have to securely and efficiently connect all of their various cloud providers at locations around the world to ensure adequate latency for applications. So, for example, if your application is located too far from the users, the latency of packets may make that application difficult or even impossible to use. So connections to that cloud provider have to be distributed accordingly, and those connections have to be the right bandwidths, have to be secure, and all kinds of things that weren't a concern when the WAN was just this single entity with data centers on the corporate campuses. Second, even before COVID, and obviously exploding in popularity in 2020 after COVID, and lingering to this day, has been remote and offsite work. So 15 years ago, most workers only tended to get on work applications at a PC in the office, often wired, literally. While now it is more common for workers to have a laptop, mobile, and tablet, maybe, that have access to corporate resources across all 3 of those devices and can be used from anywhere, effectively stretching the WAN to wherever employees might happen to be located. So even if they access WAN resources from the public internet that is not at all under the control or part of that company's WAN, that network needs to be privately and securely sent to that employee and their device so that they can get the applications, data, and resources they need to do their work. This has proved to be a major change and challenge for telecom infrastructure managers over the past decade or so, and the tools are still emerging to help facilitate this. So some tools like IPsec that I mentioned before have been around and in commercial use for a long time. There's others that are more recent or emerging, like Zero Trust Network Access, but most of these tools are designed to extend the privacy and security of a WAN to a user logging in from whatever device, location, or ISP that they are located on. So finally, related to both of these points, the security landscape for corporate networks has changed radically over the past few years as well. I could easily have done a whole episode on this, and I have done whole episodes on network security. But I think for this series, it falls out of our core goal of explaining how bits are actually moved around the world. But I thought I would be remiss not to just mention it and point out that by having the WAN to go from a clearly defined thing like a private line or MPLS network that has kind of borders and fixed locations to this internet first, cloud utilizing, remote worker, mobile device friendly hybrid has really radically changed how enterprises secure their networks. Previously, many companies relied on what we call the castle and moat system, with protections against getting into the network that were very difficult to get through, but if breached, like castle walls, allowed bad actors pretty much free reign once they were in. A lot of silly hacker movies you might have seen is about them trying to crack the network. Like, whoa, now I'm in. Now I can do whatever I want. That doesn't work with the WAN as it's set up now. Now we have to build this framework that is what we call zero trust, meaning never trust, always verify, and give users access not to just a network where they were once inside the castle walls, they could get to everything, but rather managing what users have access to on a user by user, device by device, and application by application level. So a popular security term in the WAN space now is SASE, which is SASE, meaning Secure Access Service Edge, that essentially brings together the power of SD-WAN and Zero Trust to create this framework of a bunch of different tools that work together to secure all the fractured and disparate security endpoints of the modern WAN that didn't used to exist when it was a cohesive thing. All right, so I think that goes into pretty good detail of what the WAN is. But I have to close out this fifth and final episode with our life cycle of a video. I have been using YouTube as our use case, but of course, that must be altered a bit for our corporate networks episode because a corporate employee isn't watching YouTube during work hours, right? So instead, let's imagine that HR has asked some would-be actors in the company to stay late, probably on their own time, and record a short video about how to properly fill out your TPS report. So they film the video, they fill out the TPS reports, they edit together the amazing acting with the appalling royalty-free corporate music. HR uploads that video to their cloud provider's storage nearest to the headquarters or office where this is all going down. That video is going to go through their SD-WAN device at that office. It's going to select the best performing path between that site and the nearest data center. That WAN is connected at the data center to their cloud provider's network, and it goes and sits on a server dedicated to that company. Just like in some of our YouTube use case examples, that video gets encrypted and sent across the WAN to all of the various data centers around the world. The difference here is that it won't be traveling across the public internet, but across that company's virtually private network. Now, local offices are then running a training seminar where each office has to download the video on the WAN from the nearest data center to review it with employees in the office, and of course, fill out a test to make sure that they were paying attention. There are some home workers or remote workers watching a live stream of the video training session and are connected via some kind of secure tunneling over the internet, protecting those TPS trade secrets. So really, you can see that in our example here, it works very much like the concept of the YouTube video. It's just that this is going over tunneled, kind of virtualized private connections or if they still have an MPLS network, maybe sort of really private sort of connections. But the idea behind it is really the same. It's just that corporations, enterprises need extra performance, security, and privacy guarantees that us mere consumers don't need for our traffic. Okay. Well, folks, that concludes our 5-part series on how bits are moved across the world and what the infrastructure of the internet looks like and how it works. I hope you learned something, even if you were already an expert in one or more of these areas. I know I have already learned a lot in talking to my colleagues and putting all of this together, but I would love it if I can learn even more as a part of this process. So feel free to reach out to us, find me personally on LinkedIn, let us know what you think, what I might have missed, or could have said better maybe. I'm always happy to get your feedback and hear more about whatever else you think I should cover on the podcast in general. And a special thanks to all of my colleagues who joined me to explain all of this to you and often to me, and especially to Jane Miller, our producer, for helping me put it all together. All right, thanks, and I'll see you on the internet. Thanks for listening. TeleGeography Explains the Internet comes from the experts here at TeleGeography. It's edited and produced by Jane Miller, and it's hosted by me, Greg Bryan. To learn more about our data, jump over to telegeography.com, and we'll see you on the internet.